I don't have to talk for very long for people to realize I'm not from around here. I just finished 2 years on international assignment in Australia, so hopefully you can recognize my Australian accent. But I do data center strategy for IBM, and just to put it in perspective, we have 700,000 square meters of data center space around the world on behalf of our outsourcing and our public cloud customers. And I do a lot of work with C-suite executives on what their IT strategy should be. And part of that includes what their data center strategy should be. So just to put it in perspective, worldwide, not only does ICT use about 2% of the world's energy, and that's expected to double in the next 5 years, but there's over 1 million data centers worldwide. Just think about that for a second. 1 million data centers worldwide. And here we are talking today about how Finland is going to provide a sustainable competitive advantage to run data centers of the future. So hopefully you'll put in perspective some of the information that was covered during the sessions today. And the purpose of my discussion is to give you a little bit more insight as to what is happening worldwide and how you can contain that competitive advantage for the future. So hopefully some of the things I will say will be provocative. I was at dinner last night. We had a dinner with some of the speakers. I was sitting next to the gaming person, and congratulate you because you've got to understand that this is a supply and demand game. You have to be able to provide the supply, but you have to understand where the demand was coming from. And so we were talking about gaming, and I'm a little bit older than the gentleman I was sitting next to, and so I was talking about his gaming and that kind of stuff, and I happened to mention Candy Crush. I happened to mention Angry Birds, and he just started frowning on me when he said Angry Birds is so old. Only old people play Angry Birds. You got Candy Crush. You got all this new stuff coming out. And the same is for the data center technology. The data center technology is moving that fast as well for a number of reasons, and predominantly cost. So you're going to see a lot of improvements. So the only thing I can recommend to you is understand those changes and be on the forefront of them instead of having to react to them. So this is, I can use, you're going to be an example. The question is, are you going to be a good example or a bad example? But you're going to be an example either way. And this is a slide of the IBM account and their IT. And over the last decade, one of the things that they've done is they've cut their IT budget in half over the last decade. So they went from roughly $7 billion IT budget to $3.5 billion IT budget, and it's going to continue to go down. At the same time, they've increased the amount of service they've provided, as they provide analytics, as they provide smartphone, as they provide apps, as they provide bring your own device. They've continued to provide more and more IT with less and less money. That's the norm. That's the expectation of what's driving the need for continued decrease in cost. And the data center, being a large portion of that cost, becomes a target for improvement so that this graph will continue on into the future. So you start to see a unification of the IT side with the facility side. It used to be at IBM that we had a real estate organization that provided the data center, provided the facility, and we had the IT organization that provided the IT, and they didn't really talk all that much to each other. And now what we're seeing is a blended reason for them to be together, because if you're designing data centers, you have additional synergy and value from understanding what you're going to put in that data center. So you should understand, if you're providing a supply, what the demand's going to look like, what the equipment's going to look like, because no longer are we designing data centers with uniform power and cooling across the entire data center floor. We're designing it in a modular fashion. We're designing it with heterogeneous rack capacity. So the data centers are not the same data centers as they were before. And so you're starting to see that the evolution of the IT starts to play more and more with the evolution of the physical data center that IT resides in. When we move to virtualization, and virtualization leading its way to cloud computing, when you look at what cloud computing does, one of the byproducts that it has done, especially with public cloud computing, is enabled the accounts to be much more open-minded to understanding that all that IT does not have to reside in a private data center in a private environment. So at the same time that we're increasing the efficiency of IT, we're increasing the efficiency of the facilities that IT runs in. And that trend will continue and those lines will merge. So when we look at what the business models that people are using to consume IT is going to change. We have a point of view that the future IT organization, be it a government industry or a commercial enterprise, what they're going to end up being is a service integrator for a set of service providers. IBM's the largest outsourcer in the world at the moment, and what a lot of companies have gotten used to already is a couple of service providers. They've had IBM as an IT service provider. They've had a different network service provider, and they may have a different application management service provider, but those are all infrastructure as a service providers. And now what you're going to start seeing is more platform as a service providers and software as a service providers, and that IT is not necessarily going to run in this bottom left-hand corner, which is the traditional on-site and more expensive option of people having their own data centers. When you start looking at large companies, they get some of the economies of scale of cloud computing and that kind of stuff. But the small and medium business customers and some of the other customers who aren't specializing in IT, not having the 100,000 square meter data centers that you're starting to see and exist, they're going to use some of these other models. And so one of the challenges will be, how do you market to? What do you market to the traditional company? And the answer to that is yes. But are you also marketing to these service providers, the Yahoos, the Facebooks, the Googles, the up-and-coming viral application developers? That's, again, why I was excited about games, because serious gaming has the capability of generating a lot of workload as well. And we look at the types of workload that you're going after, and you look at ones that don't require regulatory requirements. You look at ones that may not have some of the resiliency or regulatory compliance requirements. One of the things that I guide companies on is, especially the colo providers, is know who you're going to go after. If there are 1 million data centers out there, know which is the target workload and kind of specialize on what area you're going to provide. So, but understand just from this slide, knowing that the model that people are consuming IT are going to change. And it changes at different points in time when they're filling up a data center, waiting the ability to burst workload to a cloud and bring workload back. All that technology is becoming available to kind of drop the cost. And there's different price points depending upon what business model you're using. And it's a multiple choice answer here. In other words, they're not going to have 100% of their IT all in one model. And one of the things that you'll work with the companies to do is to stratify which workload works best in which models. Some of the cloud providers are targeted at optimizing certain parts or certain components of workload, like some are optimizing on storage, some are optimizing on network. So if you have a heavy network intense application, you'd pick this cloud. If you had a storage intense application, you pick that cloud. You've got to understand what your market is and what target audience that you're looking to provide your data centers of the future. So a lot of discussion have gone today about site selection. Rightfully so, some of the most important things, and there were excellent topics today on this, is understanding the power and cooling and understanding the energy demands because as companies continue to grow their IT workload, they're also growing their dependence on IT. So the need for the data centers to be up and the resiliency and better living through redundancy that we've had because we put extra equipment on the floor to be able to handle power outages through UPS and generators, you're starting to see that move away as companies move more to more resilient power sources. So you've got these different things, and what we do when we do site selection at IBM is we have a weighted criteria of about 100 different areas in these six major categories. And what you can see when you look at up here in Finland, that there are natural things based on the weights that you have a competitive advantage. And from not only from pre-cooling and energy and renewable energy and being green, but just keep in mind, as Ian talked about before, that isn't the only thing that people make their decisions on where they're going to put their IT workload in the future. So just understand these other areas that exist. I did a piece of work about 5 years ago on using Iceland for IBM internal workload and IBM customers' workloads. And just to give you an example here, at that particular time, they did not have redundant network capacity either back to Europe or to North America. So they've since changed that. But there are technical reasons and what I call political or non-technical reasons why people will choose one data center over the other. And you'd be naive if you didn't understand that. And at the end of the day, even though they were going to fix that network problem, and that was a technical problem, there was a non-technical issue or concern of customers that we couldn't find that were receptive to putting their workload in that island. So understand that you've got the technical forces that are driving data center content decisions and data center strategy, but you've got these non-technical reasons as well that you have to address as well. So we look at what is driving the technological change, and some of that is improvement in the technology itself, and some of that is improvement in the price performance of the technology. There was a chart before about PUE. This chart on the left, when we're building data centers, we kind of look at these as guidelines of how much does it cost to build a data center, in addition to how much does it cost to operate a data center. And so you can see that we are starting to attack the largest portions of this pie, with over 50% of that being the cooling distribution and electrical distribution of a data center. So that's why you're starting to see, can we make it so we don't have to have chillers? Google Data Center here in Finland is an excellent example of using seawater as cooling and not having any chillers, because chillers are the most expensive component of the cooling distribution system. Likewise, when we look at the power, we're starting to see how do we replace the UPS and generators without sacrificing the degree of availability within those data centers. So that's what's driving. There'll be continued improvements in the technology as well. Even stuff like the shell of the data center, you're starting to see continued use not only of energy in areas where there's no longer paper mills or there's no longer textiles, but because of these lightweight manufacturing areas, they also make perfect locations and criteria for data centers as far as the ability to sustain the weight of the equipment and some of the other characteristics. So we're seeing people reusing the buildings as well, driving down the cost because they don't have to build a building. They can use existing building, they can use existing power and therefore come online quicker. Likewise, we start looking, you see the Schneider Electric charts around here talking about a modular design. And this is the modular design not only for the data center, but for the IT as well. Companies are moving away from ordering servers one server at a time and having server modules similar to having data center modules. So IBM announced in first quarter, SoftLayer was going to build 25 new locations. And they were 1 megawatt locations, and they would have them available by the end of the year. So in 6 to 9 months, we would do 25 new megawatt locations where traditional builds used to take 12 to 18 months. But the smaller you make the modules, the quicker the modules can come online, and the more you match your utilization with the capacity. In other words, you don't overbuild and wait to fill it up again, because you can kind of see the cost differential of doing that. So you have modular designs. Just keep in mind you want modular designs both for the data center and for the IT that goes in the data center. To give you an example, our first dev test public cloud was a 10-rack implementation that had server storage and integrated network. So you're going to start seeing integrated devices and integrated modules. So that also changes some of the skill of the people. I got into discussion about managed service providers and skills needed for the cloud and skills needed for the future. We're going back to a little bit of a generalist model because they're going to need to know a little bit about storage, network, and processing capability to be able to set up and operate these modular environments. Likewise, when we start to look at the cost, when you look at where these million data centers are looking at, and you look at the level of resiliency, what's driving the PUE or the effectiveness of the efficiency of the data center itself is predominantly a function of how much redundancy you have, whether you've got UPS and generators, whether you've got a spare for every major piece of equipment or twice the amount of equipment, so you have a one-to-one mapping of your equipment so that you can use that for preventive maintenance or upgrade. So it's a function in the tier level of the amount of redundancy you have, and also the climate that you're in, as long as you're using the climate to your advantage. We talked about free cooling, but we're also seeing in some of the hotter climates them using solar panels and other technologies that become cost effective to use to improve their PUE as well. So this trend will continue, and there's going to be additional technology being developed to lower those curves as well. So you're seeing the trade-off with the tier level between what level of service, what level of availability you have, and as the utility power becomes more resilient and 5 nines and that kind of stuff, you need less redundancy, and the level of risk that you're willing to take, and the timing of what technology. A lot of times technology isn't adopted because of the fact that we're in a brownfield environment with most accounts that have to wait 5 to 7 years for their server equipment to depreciate, or have to wait 10 years for their network equipment to depreciate, or 15 years for their data center equipment to depreciate. So you've got to understand where accounts are in their financial models to understand what would be the right approach. So if you were to look at new workload today that you would want to put in your data centers, what you would look at is new workload, the new born on the web and the new apps and the new games and the new stuff, the systems of engagement, the social media stuff, because that's brand new and that's growing and that can be on different platforms than the traditional workload that they're already invested in and have to wait for that investment stream to play out before they can move the workload. So we look at cooling considerations. I mentioned the fact that we're starting to see more air and water side economizers. Radiators existed 5-10 years ago, at least that. How many people have a radiator in a car? So the technology had existed and been perfected for quite some time, but it did not become economically feasible to do in data centers until the cost of the technology came down and the cost of electricity goes up. So in areas where the cost of electricity goes up, a lot of these business cases are closing for advocating data center consolidation, and as long as they're doing data center consolidation, they might as well do data center consolidation to Finland. So we look at, I talked already about the fact that there's non-uniform distribution when we look at rack density. We still have low rack density equipment and high rack density equipment, and just caution you about using a modern data center that is designed for high density by putting low density equipment in there. Because what you'll end up doing is you'll end up using the power before the space or the space before the power, and therefore you'll have stranded capacity either in power, space, or cooling, and therefore can't run as efficiently as you would like. Talked about the modularity of ordering modules and therefore making the bill of materials, the ordering, the capital improvement process, the number of times it's much easier to order 50 servers at a time instead of ordering one server 50 times. And when you have it integrated with the storage, because usually when the servers need to get upgraded, so does the storage technology, so does the network technology. So you usually have to integrate the three of those but by optimizing and just upgrading one of them, you don't get the benefits that come associated with the other two. Previous session today and a couple of them mentioned moving up, increasing the temperature of the data center. And you'll find that for several years, the vendors have been warranting their equipment to run at 40 degrees Celsius. And now we're starting to see the fact that there's a critical mass of that equipment so they can segregate it. And if they're modularizing and having sections of data center, they can devote those to running at higher temperatures. And by running at higher temperatures, they run more efficiently because you don't have to allocate as much cooling to them, and a lot of the free cooling techniques will be more efficient in those higher temperature data centers. And we're starting to see on-site power generation as a result of a couple things. Finland has the advantage of having high quality power where a lot of the other locations in the world do not. So what we're seeing with those is a movement away from utility power, and the cost associated with on-site generation is becoming technically viable, especially when you range from United States, which is like 6 cents a kilowatt hour in some locations, to India and some of the other places that are 18 cents per kilowatt hour. The business cases close at different rates as you go around the world, and some things are more viable, and you'll see these technologies show up in different places because of the economics, not because the technology doesn't work. Likewise, when you start seeing there's going to be new winners and new losers in the data center as we move away from the UPS and generator model, we move away from disaster recovery, we move away from some of the other forms of redundancy, that there's a fundamental shift in the industry that people are going to need to respond to. So we look at data center information management. I talked a little bit before about the fact that the IT and the facilities people didn't used to talk to each other as much, and the need for that now. Not only the people talking, but the equipment talking. Because what we're able to do now used to be that air conditioners were on or off. There was no in between. Now we're starting to see variable frequency devices, variable frequency drives, fans. And so the ability to sensor the data center and understand what the IT of the equipment is, and to be able to dynamically create heat maps and airflows within the data center enables the, with additional analysis, to be able to ramp up and ramp down the cooling to specific areas of the data center, and that's much more efficient than running everything at a high end. Likewise, there's a lot of redundancy in the crack units. We're seeing companies turn off some of the redundancy when they know that they can ramp it up. Likewise, a lot of the crack units aren't running at peak efficiency because there's so many crack units, and just the sheer act of turning them off ramps up the utilization of the other ones. But you have to be careful in knowing which exact ones to turn off because of which ones affect which area of the raised floor. And I'm talking in a raised floor or in an area, an open area. So you're starting to see a couple things. One, Internet of Things, more sensors. We built a data center in Raleigh, North Carolina. The facility side had 10,000 sensors. When we look at each of the pieces of equipment and the monitoring that we put in place for those for basically a 6,000 square meter addition to that data center. So this interrelationship, again, between the facilities and the IT is showing up. Metrics, I had a friend tell me my first week at IBM, if it's worth doing once, it's worth doing 2 or 3 times at IBM. Likewise with metrics. There is no one single metric that measures the efficiency of the data center. PUE comes the closest at measuring the efficiency of the facility side of the data center, but it doesn't go down to the component level, nor does it measure the IT side. So what you're starting to see is these additional metrics mature similar to how PUE matures in measuring different parts, whether it's carbon or water usage or other things to measure the efficiency of the data centers. I'm on the board of directors of the Green Grid, and I just reviewed the papers on space efficiency as it relates to power, and also storage efficiency as it relates to power. So there will continue to be more metrics that you will want to understand. And these metrics, you don't do them similar to certification. You don't just do them to spend the cost of certification. You do them and you implement them to understand, are the changes that we're making cost justified? Are we getting the changes that we anticipated and the improvements that we anticipated from the technological change? So you don't just do metrics for metrics' sake. You don't. There was a bragging war in the U.S. about my PUE being better than your PUE, and that's not what the intent of it was. The intent, like the data center maturity model, is to be able to understand where you are and where you're going over time. So you look at the EU Code of Conduct for data centers. It's one I've advocated for years because of the fact that it does have a much more holistic appreciation for not only reporting, but to have an element to go past that to say, well, what are you going to do to continue to improve? And the fact that you have to turn in the metrics kind of keeps you a little bit more honest as well than keeping that information internal. And we're starting to see, as Ian points out in the session a couple sessions ago, that around the world you're starting to see efficiency metrics being put in place. A little bit of churn there because each of them feel like they want to add on to what's already there. So when you start having 100 countries do 100 metrics and 100 standards, you have to keep track of all the differences between them. So what we'd like to see in the industry and what the Green Grid's trying to foster is crying for multinational corporations and to being able to move workload between nations, that you try and standardize on some of these metrics as well. So when we look at the Green Grid, I'd be remiss as a board director without mentioning it a little bit, but their shift and our shift has focused it a little bit. We restructured not only to look at a little bit more geographic coverage, but we restructured because of, quite frankly, some of the walls of the data center are coming down when you look at bring your own devices, when you look at distributed IT, when you look at how powerful the presentation layers are that customers have today. We're going to continue to reinvent ourselves and redrive different purposes and different investments within the Green Grid to respond to continued improvements that we see that need to be made in the data center. Data center maturity model, already mentioned from the standpoint of here's where you are, but here's where you can be. So if you think you're doing good, but you're not doing as good as you will eventually be based on the change in technology. So I always caution my customers, if you're putting in a new piece of technology, be a new data center or a new piece of hardware or a new piece of software, think about when you're going to have to replace that technology as well, because there'll always be the next greatest thing that comes out after that. And your ability to understand, like with this maturity model, was intended to come up with the next block of the next technology that you'll be able to incorporate into your data centers over time. Their forum, Green Grid Forum, is coming up next month. This is the agenda. What I wanted to call to your attention was the different areas and the different tracks. When we look at the maturity models, what are the technologies? What's the benefit on the IT side? Talk a little bit more about the utilities and the power and cooling distribution, and then the life cycle of a data center. A lot of people have asked me how long a data center should last. And I said, well, quite frankly, I don't know. And why can I substantiate that answer? Because the data center that I was hired to run more than 3 decades ago still exists and is still a useful data center because it's been in a modular fashion and been modularly upgraded. So keeping in mind that that's the design point and criteria you want to have, you want to be able to continue to upgrade these, will extend the life and therefore decrease the cost of your data centers over time. So here's the things that you're doing good that's going to continue. Virtualization is going to continue up. In the industry, it's roughly about 60% around the world. There are large standard deviation to that distribution. I was working with a company who I thought was dyslexic because they had 16% adoption, not 60. But there's some companies that aren't growing the virtualization. The virtualization makes moving cloud computing easier, makes moving workload between data centers for data center consolidation easier. We'll continue to see not only new improvements in building new data centers, but continued improvement in legacy data centers as well. Rack density is going to continue to go up. You may be aware of the fact that IBM manufactures hardware, designs hardware. We continue to talk with our hardware developers, and they're continuing to design equipment that runs at higher rack densities. I talked about the site selection. Data center consolidation is cost justified. A lot of companies have grown through mergers and acquisitions and do not need all the data center resources that they have. Again, a source for new data center opportunity. It was interesting, I was working with a bank in Germany, and we had laid out a perfect data center strategy. It was impressive, it had these upgrades over this year, multi-year, understood the demand, understood the forecast, mapped the supply and demand, got them more efficient and higher utilization than they had ever experienced before. One thing, they had a new CIO came in and said, we want to change the one assumption that you had in your plan that 0 of that technology and workload was going to be in a public cloud. I want to make that number 30. Therefore, invalidated all that work as far as being able to redesign what their new data center strategy would be in light of the fact that the new CIO was willing to take a risk and willing to move some of the capital of the data center and the capital of the equipment and get that off their books and move that to a different service provider. When we look at IT per company, will continue to go down, and their spending on enhancements, new workload, will continue to go up. Make sure you understand the mismatch between running out of power versus running out of space or cooling, the modular approach. So here's the fun part, the disruptive stuff. Here's the stuff that's going to define new winners and new losers. And so we look about being able to run data centers incrementally as we increase the temperature, as we drive toward 40-degree data centers. As we move to virtual workload, there are now techniques to be able to dynamically move workload between data centers. So we're going to see a lot less lift and shift as the method of moving equipment, not only for that reason, but because we don't want to put old equipment in new designed data centers. Ordering these modular IT, ordering a footprint of data centers and being able to understand as we increase our virtualization that there's less of a need to have a dependence on a specific device type, be it server, storage, or network device type. Looking at continuous availability. One of the things, we don't advocate, we don't have a lot of, although we do have some in our portfolio, the two-end redundancy implied by a level 4 or tier 4 data center because of approximately a 30% price increase in going from tier 3 to tier 4. But now what you're starting to see is companies moving away from disaster recovery by moving from an active-passive set of workload to active-active or active-active-active, where they can run the workload in multiple data centers. So if any one data center takes a hit or is down for upgrades, that workload continues to go on. So the question is, where does the redundancy exist? And you'll start to see more and more of that redundancy and parallelism exist in the application as well as the data center. Reprovision versus restore. A lot of companies have 1,000 images of Windows, or 2,000 images, or 5,000. I was just working with a company that had over 100,000 images running live. Do you understand if they backed it up once a week or backed it up once a month, each system, how many copies of Windows they actually had? And yet, if you look at how much time it took to restore those particular image, but yet they've invested in cloud, they have a service catalog, they've got a provisioning engine, that they can more easily and more accurately reprovision the image instead of restore the image. I'm talking about the image, not necessarily the data. The data still needs to be backed up. So we're seeing with the cloud and seeing with new technology, people's fundamental mind shift in leveraging virtualization techniques, leveraging provisioning techniques, because these new techniques will get them their end goal of a higher available, higher service application using different technologies that are being developed. Dynamic resource scheduling, just an example of the ability to pool resources and being able to move resources between that pool so they can have a smaller overall white space because of the fact that they can dynamically move workload. And this new thing called the software-defined data center, software-defined networking, which will ease and revolutionize moving workload between data centers, as it kind of eliminates these issues such as hard-coded IP addressing, being able to extend the network to the data center that you're moving. So all of these are going to redefine the new data center, redefine the winners and losers, and I just recommend to the people in the room that they take these into account going forward and create that sustainable competitive advantage that you've already started that journey at the moment. So hopefully I've said something that's been provocative from the standpoint of provoking you to change how you're doing what you're doing, both now and in the future. I'll just turn it over for, I think I'm running a little bit behind schedule for closing comments. I'll be over in the reception.
Yeah, I was about to say,
that you can yell at me that,
Chris,
that I got it all wrong.
That was about, as a summary presentation, that just about put this whole audience in the picture, not only now, but the future. So I think that was fantastic. Thank you. And what I would say is there's the opportunity in the cocktail party. We are, as I said, lucky that Chris is about, and I'm absolutely sure he's willing to engage with anybody to have a chat over there. I need to close this, and you'll see in the program there's like a 40 minutes close. So the good news is there is nowhere near a 40 minutes close. And the first thing I want to do is make no apology. Can you just, sorry, I must say thank you to Chris. Put your hands together for Chris. Thank you, Matt. Brilliant.